Hey there, this is Seth Juarez from Channel 9 coming to you from NDC Oslo in the beautiful country of Norway. I'm here with a special guest. Why don't you introduce yourself?
Yeah, thank you. Hi, I'm Patricia. I work for the Vivaldi browser. I'm a C++ developer, and I've been that for 12 years now.
12 years, okay. So tell me a little bit about working on a browser. 'Cause first of all, for those that don't know what Vivaldi is, why don't you describe what it is?
Vivaldi is a browser. It was started by the same guy who started the Opera browser.
Okay.
So, and I used to work on the Opera browser earlier from 2005 to 2009. And he started a new browser company, and it's sort of the same kind of vision of being focused on the user and that people are different instead of trying to find the common denominator, letting people customize their browser to their own needs. Yeah.
So tell me about what kind of customizations are we talking about?
Oh, it's all sorts of things. You might want to set up your own keyboard shortcuts. You might want to do your mouse gestures. You can have stuff in panels. You can put your tabs on top or on the side or on the bottom or wherever. And so those are the kinds of features, like if you have something that makes sense in your workflow, like you used to using Vim and that's kind of the way you work, then it's designed for people who like to customize because maybe they're in their browser a lot.
I see. So tell me, what part of the browser do you work on?
Currently, I'm working on the media integration. So for proprietary codecs, because we are a small company, we don't have patents and we can't pay them because we don't have that kind of money. So it's we have to use GPU decoding or maybe a package that comes with the distribution, and so that's a whole module. So I've been looking at that, trying to fix bugs, refactoring, trying to get more tests.
And so for example, when a video is loading up in the browser, there's a video tag, you have to be the one that actually makes the video run.
Yeah, if it is proprietary codec used, like if it is an open codec, then it will go to FFmpeg, like Chrome will do, and it can take care of it. But Google, they have patents, so they don't have to worry about it. So they can send everything to FFmpeg.
I see.
Whereas we have to do some of it.
So what does that work? So let's get into the nerdy aspect of it. What does that actually mean? Are you getting an array of bytes and you have to do stuff with it?
Yes.
So what do you like? I mean.
Well, generally, it's like we don't implement our own codecs. It's generally we're using codecs that are on the platform. So on Windows, you would use a media framework. On a Mac as well, a media framework that you have to make a standardized API towards, and then you're passing bytes into it. It will pass bytes out, which we have to feed back into Chrome. So Chromium.
I see.
So it's not that I'm doing the decoding myself, but this has to be piped over to the GPU process because these frameworks oftentimes use the GPU to decode media.
I see. And so Vivaldi is based on the Chromium base.
Yes.
And then you're building on top of that.
Yeah. So it's like Chrome, like Opera, like the new Opera that is, and Brave browser, and many other browsers. Yeah.
So let's talk a little bit about C++ because I have not written any C++ since I think the last thing I wrote in C++ was the minimax algorithm to do games in college. So tell me a little bit about C++. How has it evolved since that time? What are some cool things in C++ that I should know about?
Oh, wow. The last 4 years or 5 years have been really interesting because it stood still for quite a long time, but a lot of very new features are coming in, and especially what I like is a lot more standardization of APIs. Like we didn't have a cross-platform way of doing threads. It was a platform-specific threading. Now we have a cross-platform threading API.
Oh, nice. And does it point to pthread on Linux and something else on Windows?
So that it depends, how it's implemented depends. But from a programming perspective, you don't have to worry about it because the semantics and the API is the same.
That's nice.
And you also have file API that is. It's funny. It's like, okay, if you're coming from other programming languages, this is you never had a file API, but we didn't. And we have a very good time and clock API for if you're doing real-time stuff and you need good measurements and audio processing and stuff like that. So now we have a cross-platform chrono to do that. So, but also it's more it's moving more in a functional direction.
What do you mean? 'Cause I can't imagine, because I'm remembering C++ with like the constructor and the destructor and the old H files and the CPV files. How do you make that functional? Let's describe that.
They're moving, like we always had like function pointers and stuff like that. So you always could pass functions as parameters, but it's moving to more like we can have lambdas now, and we're in like the algorithm section of the STL. You have parallelized the algorithm, so you can. So there's a lot of really cool stuff. So you're moving more towards like a MapReduce kind of programming,
I see.
and so it's sort of like we all that are programming C++ now, we need to like sit down and learn it all over again. Start to program in a different way.
Is it that different that you're literally programming a different way?
I think so. It's moving more towards like a functional or like weakly typed languages in the way it looks, but it is still strongly typed. Like we have auto now. You don't have to write like the
whole.
Yes, it's like it's you're looking at it and it's looking more and more like JavaScript.
But it's definitely not behaving like JavaScript.
No. It has the performance and it has the memory features of C++, and it is strongly typed. But when you write it, it looks much more like those kinds of languages.
I see.
And so if you're coming from that kind of background, it will make more sense. And culture-wise, we moved very much away from allocating memory with new, and so as long as you're kind of following the culture, you're generally okay memory-wise as well. So I think if you're ever going to learn C++, then learning modern C++ is probably the way to go.
So let's talk a little about memory management, because that was something like I still remember. The reason why I remember that assignment is because the dude ran. What did he run? There's this memory leak program that checks. What's it called? I don't remember what it's called, but it was on a Linux machine, and he ran it and he checked for memory leaks. And mine had like so many memory leaks. I wrote it the night before that I got like a C. It was like the one C. That guy, man, Minimax. I didn't get it right. What is memory management like? Because you said something about it should be okay, and I've seen static languages like Rust, for example, do implicit deallocation of memory and passing around references in a smart way. Does C++ do that kind of stuff?
Yes, but it's more convention. It is not enforced by the language. So if you're coming from a Java background, you're used to allocating your memory with new all the time. Right. But if you're learning from an experienced C++ developer, you will very soon see he or she hardly ever writes new. So almost all allocations are stack allocated or has some kind of stack feature that holds on to the reference. And so when the code goes out of scope, the thing is automatically deallocated.
So you're saying you're never like doing malloc type things into the heap?
No.
How do you write that? Are you just passing a lot of stuff everywhere?
No, the thing is you can pass references to objects that are on the stack, and then and if you have to allocate things on the heap, you generally wrap it in an object that has like a handle to that memory, and then you put that handle on the stack, and when that goes out of scope, its destructor will deallocate. So you generally never write delete or new. It's like a style, but the thing is that's the problem. C++ is sort of a language you have to learn from someone, because you can do anything, but it has a culture and it has a style of programming that you kind of have to learn from people.
This is like super good information for me.
Yeah.
Maybe how do you put? I thought the stuff that went on the stack was only the parameters you passed in function calls. How do you get other stuff on the stack? And maybe this has been a long time.
Like in Java, when you declare a pointer, if you write the same kind of code in C++, you're allocating an object on the stack of that type, calling the default constructor. So you write object O semicolon. Okay, now you just allocated an object of type object, and it's allocated on the stack, and it has a name, and that is O.
I see.
So you don't have to. It's very. But the problem is, if you're coming from Java, you don't understand what's going on at all, because it looks like you're declaring a pointer, but you're actually making an object.
Is it now? Is that object have memory assigned to it and everything?
It has memory on the stack.
But it's a null object. If you just do object O, it's null.
No, it is.
It's the default whatever constructor.
It's a default constructor. If you just put semicolon, it will call the default constructor the empty constructor if you have one. If not, this won't compile. But if you want to call another constructor, you just add parentheses before the semicolon and you add the parameters to it. But that is the allocation of an object on the stack.
So why would you ever use new if that's the case?
We don't. No, it's like most of the time, like if you want to allocate something very big, like you have a huge buffer, then you might put that allocation inside of another class. And when you instantiate that class, then that's the part you put on the stack. So it's a very small object that has a pointer out
to the heap.
But in this class's destructor, you will deallocate.
Yeah.
So you will never, like when you define this class, then you will have a new and delete. But when you use it, you will never actually new or delete anything because it's automatic.
Well, I just remember the malloc and free days from C,
Yeah,
and that you're saying like if you're clever, if you do it the right way, you never have to worry about memory.
Yeah, no, we don't worry about memory.
So
much.
like the stack is finite, right?
Yeah.
How do you okay, I see what you said. You said that you only put, like if there's something that's going to be huge, you put a wrapper thing onto the stack that points to this thing on the heap.
Yeah, and there are predefined classes for that. Like you have things like shared pointer, which is a reference counted thing, or you can have a unique pointer where there's only one, and then so then you don't have to worry about it. It will call your destructor automatically. You just kind of wrap it in this thing, and yeah.
This is amazing. So like I remember using new all the time, and I'm vaguely remembering someone said, "Don't do that."
Yeah.
But I didn't understand. Thank you. Now, two people now are telling me, but I didn't understand why at the time. But now it makes perfect sense.
No, because people are not very good at teaching it because they teach it like and you see that in all programming languages.
Sure.
When they teach it to you, they teach you the syntax. But syntax is not very interesting. What you need to learn is the culture and how do you program in this language? What do the good people do? Like how do they structure their programs? And that's culture, and you kind of have to learn it from a person.
Sure.
It's not syntax.
So what is something else that I'm like told, like, cause that, like it blew my mind because I'm like, that's so simple. Why didn't I ever do something like that? Because the stack is really smart about how things are managed. What are some other culture things that you think people should know about if they're doing C++? That's like a tall question because like you're probably doing this kind of stuff innately.
Yeah. No, I usually notice things when I start programming in another language. Like one thing that I will notice is that a C++ developer are usually very interested in how things work. And so when I move to and work with JavaScript programmers or Java programmers, they're very used to using a framework like a black box.
Sure.
You put something in and then something comes out, and if it doesn't, then you Google it and it's on Stack Overflow.
Right.
But if you're a C++ programmer, you generally will download the source, you will read through the source, you will understand how it works, you will make a patch, and you will patch it. So it's a different kind. We're used to rolling our own and everything, so you have to dig down and understand how everything works, which is weird. When I started at Vivaldi, the UI is in React.
Yeah.
And I'm not a web developer, so the first 2 weeks I spent reading the React source code.
And that's some complicated stuff. I mean, it's not easy stuff.
But it's all right. It wasn't that bad.
Yeah.
But the thing is, all of the JavaScript programmers were like, "What are you doing?"
It just works. Are you sure? I need to look at this myself.
And then I actually had a presentation where I went through how it worked, and then in the newer version you have the React Fiber. So I went through and explained how React Fiber worked.
She's awesome. That's awesome. So there's another thing you're passionate about that you wanted to talk about. Why don't you tell us about that?
Yeah, no, I'm coming, like, as a C++ programmer, it's, like, women in tech is oftentimes a minority, and but as a C++ programmer is a massive minority. I'm usually, like, I've worked 10 years professionally as a C++ programmer, and I've never think I've been in a country or a company where I've been over 2% women being programmers in C++. And so generally I will never ever work with a woman. And very oftentimes when I'm put in a team, I will be the first woman they've ever worked with.
In C++?
Yes.
Do you think it's a language thing or a culture thing? I mean, but I mean by language, it's like, I mean like C++ versus Java versus JavaScript.
It might be. It might be also like, it might be that it's not taught that often, and when it is taught, it's oftentimes in the sysadmin kind of things, not so much in universities where you learn computer science. They will pick a different kind of language. So I don't know, but what I do feel is that we need to put more diverse people in the room, and that's not only women. That's people of color. That's people of that have handicaps, like people who read languages right to left. there are so many programs that don't handle right to left languages in any kind of sensible way.
Right.
But if these people were on the team, then this would have been right from the start.
Right.
And all of those image processing applications where they don't work if you're black, they would have worked if you had a black guy on the team or a black girl on the team. And it's just, you have to, if we're going to make software for everybody, then everybody has to make software.
So how do you do that as a company? What are some suggestions that you have that would make this a little bit better?
I think right now, and in the industry, we're talking a lot about recruiting, but also you have to think about when you get these people in, that you have to take care of them, because because these people are oftentimes the first or the second, but it's still, there might be culture problems, you might have harassment or sexism, and you need to protect them. So you need to take care of them when they come in as well. It's not enough to recruit them, because if they're mistreated, they're gonna leave.
Right.
And you have to, you're in the same place again. So, but I often think that people don't realize that I think this will be better for everyone. I think it will be better for white men, heterosexual men. I think they will love having different kinds of people in their teams. I've talked to people many times when they say, it's like, things were so much better after you came on the team, because we're nicer to each other. We don't swear that much, and people aren't that rude.
Right.
And everybody benefits if we kind of bring everybody together. But we have to talk about it, and we have to be able to confront our own unconscious biases.
Sure. So what is a I've heard the term ally before.
Yeah.
What is a way that, for example, I can be an ally to have more diversity in the kind of work we do in tech?
I think being an ally in many ways is speaking up when you hear something that you don't think is right. I think that's the best way for your male peers to realize that this is not all right, is for another male peer to say, you know what, that's not cool. I don't like that. I don't like that you talk that way. But if you're in a meeting and you see that a woman says something but nobody's listening, and then a little bit later your male colleague will say exactly what she said, and everybody will go like, oh, that's such a great idea. Then, you don't have to make a big deal out of it. You go like, yeah, it's really good that you're saying what Sarah said earlier. Yeah. I thought her idea was really good. It doesn't have to be awkward and confrontational. It's just trying to lift up people. Like if you have a woman and she's having really cool ideas, to bring it up, because then you're using your privilege to lift her up, right? So you're saying, I would have had a talk with Sarah, she had some really good ideas, we really wanted to present that. Or bring people with you into situations. And,
that's awesome.
Yeah.
So you were telling me a little bit about how you started speaking. Why don't you tell us about that?
Yeah, that was weird. I was when we were at Cisco, and we were having an internal conference, and it was like about women in tech, and I thought it was kind of dumb, and and I was sitting there, and especially because it oftentimes ends up being a management thing, where there's like, how can I become make my career or something, and I wanted something to be more technical, and I was like, can't we have a female technical speaker? And they were like, yeah, but we can't find one. And I was like, oh, come on, there must be possible to find like a female technical speaker in Norway, right? Yeah. And so I'm looking around, and I was having a really hard time. And then I got like annoyed, and I said on the chat, I said, come on, I want a role model.
That's awesome.
And then this girl came to me, she said, well, I think you're a role model. You're a role model for me.
Sure.
And I was, what?
That's cool.
And then you just have to consider, what had I done? Right. I had never done anything. So I'm trying to just speak up so that somebody else will speak up.
That's awesome. So that was like, you're like, I want someone to speak from my demographic. And you're like, well, I'm from that demographic.
Yeah, and I'm not doing anything.
Let me speak. Right? That's a really good idea. Tell us about the talks you did here.
I was talking about Linux security APIs and how they're used to construct the sandboxing in Chromium, which I think is really interesting.
That is really interesting. Man, how much time do we have? We have all sorts of time, right? They're giving me the time. So tell us a little bit about what you talked about, because because you're like really down there in the bottom of the stack there.
Yeah, but there's some really, really interesting APIs there, and they're used for many different things. Like most people that are not maybe browser interested, these same APIs are used for things like Docker, so you can have containerized views of a Linux system. So it's the same kind of APIs that are used to make Docker containers that are used to make sandboxing for browsers.
Interesting. So effectively, when you're spinning up a Chrome browser, you're spinning up like a container.
Yes, but many different containers for the different types of processes. They're not Docker containers, but they're like specialized containers for these specific processes.
So how do these processes get isolated?
That's sort of what I go through in the talk, where I describe how to make a sandbox. It's a stage-wise thing as you create the processes. So you can, as you fork child processes, then you have to put in limitations as you go. And the last stage that you have many different stages, like you're isolating it from the network, you're isolating it from the file system, you are isolating it from system calls, so you're saying I am only going to allow this set of system calls. You're giving it a world where it can only see itself as a process, so if it tries to view other processes,
right,
can't see them, or other users on the system. And so it's like you're trying to put this process in a state where it believes it's in its own world, but that world is limited.
How do you do that? How do you make a process not do system calls, like for example, right? Because it's trying to call into the kernel from user mode. Mm-hmm. How do you prevent those user mode transitions into kernel mode?
That is actually very interesting. I have seen some other people here talk about it, but this was actually a functionality that was created for TCP dump. Because in TCP dump you want to filter packets because you want to maybe inspect them or something, but the amount of packets is so large, and it's going through the kernel, and you need to pass it to a user space application, and this cost of crossing the kernel user space boundary is very big.
Sure.
So you don't want to pass stuff up that the user space application isn't interested in. Mm-hmm. So they created a programming language which is called BPF, which is Berkeley Packet Filter.
Okay.
Where you can write a program in this language. It's sort of like an assembly-like language, where you say, if I get this, then I want it. If I don't get this, I don't want it. And then you can basically write this program, and then this program is installed in the kernel.
That makes sense, because otherwise you're like shooting interrupts into user mode all the time for all the packets, and it's just like paging in and out all the time.
When it sees a packet, it will run through your program, figure out if you think it's interesting or not. If you think it's interesting, it'll pass it up.
But from the kernel side?
From the kernel side.
Smart. And so that's the kind of thing?
Yes, and it's been being used for many different things now, for profiling and for seccomp, which is where you intercept all system calls from the application. Mm-hmm. It will run it through this program to figure out, is it allowed? If it's not allowed, how to fail?
It's like filtering system calls.
But you can also fail in safe ways. Like you can say, like, I'm just going to fail with an error code. So, or I'm going to, if somebody calls this function, then I'm going to crash the program. So you can basically specify exactly how you want. So it's used in Docker, it's used in sandboxing, it's used many places.
That's amazing. And so that's a really good analogy. You went from the Berkeley packet sniffer to, because the kernel is going to shoot stuff mm-hmm. up, into now you're putting something into the kernel that's going to intercept things from user mm-hmm. mode and filter them, mm-hmm. which is kind of like the reverse.
Yeah.
That's really clever. Now, did you read through the source code for that? Because I would have never.
No, I've been very interested in these APIs because I find them very interesting, mm-hmm. and I knew that they were used in the sandboxing. Mm-hmm. So I used those two things to say, okay, I'm going to pitch it as a talk because I really want to dig into it. So I did, and I got to present here.
I love the idea of submitting an abstract of a talk for something you really want to learn. Guilty. I do it all the time. Well, it's been really nice talking to you. Where can people go to find out more about what you do? Do you have a blog or something?
You can go to my Twitter. Mm-hmm. I try to tweet a little bit every now and again, and you can tweet at me. If you're a minority in tech, I'll probably follow you back if you follow me.
Sure.
Because please, just get in touch.
Awesome. Patricia, it's been awesome talking to you. Thanks so much for watching. This wraps up day 2 coverage of NDC Oslo. We'll be back tomorrow at 9 a.m. with a session, and we have tons of cool people that we're going to be talking to. Thanks so much for watching, and we'll see you tomorrow.